তোমাদের যদি কোনো সমস্যা হয়ে থাকে, যদি ইন্টারনেটের সমস্যা বা নেটওয়ার্ক আসছে না বা ডিভাইস নেই, ইউ জাস্ট টক টু দ্য টিচার্স। কিন্তু the official class is going on. If you don't attend, then you will lose something. That I can assure you. তুমি যেখানেই থাকতে পারো, রিমোট ভিলেজে থাকো, যেখানে খুশি থাকো, but you have to arrange your connections. You have to arrange your device somehow. যখন একটা সেমিস্টার পুরোটাই ক্লাস না হয়ে গেছিল তখনকার ব্যাপার আলাদা, কিন্তু এখন যে ক্লাসগুলো হচ্ছে these are all official classes. এখানে তোমার ইচ্ছা মতো তুমি এটা করলে না করলে তুমি করতেই পারো, কিন্তু তার একটা রিফ্লেকশন থাকবে কিন্তু এভালুয়েশনে। That I can ensure you. Okay. So, okay. So I will start third step today. So another name is called silicon control rectifier. SCR. So this SCR or this thyristor is basically a 4-layer device. As you have seen, the diode is basically 2-layer device. Okay, and the transistor is a 3-layer device. So layers are basically NPN or PNP. Okay, but this particular device, which is called this silicon control rectifier or this thyristor, is similar to this bipolar junction transistor by which we can control the power electronics devices. Is a control rectifier, but it has 4 layers. So that is the difference between the other devices like BJT or MOSFET. So it's a 4-layer device. So let me draw the layers. So this is the N layer, this is the P layer, again N layer and P layer. So NP, NP. So here this is called the cathode, just like the diode terminology, and this is called the anode. Okay, and one more terminal we have, because it's a control switch, unlike the normal diode, it's a control switch. So therefore we have one more terminal, and that is called the gate terminal. So this is the gate terminal. Okay, so this is the real life structure of SCR or thyristor. Okay, and the symbol by which we draw this in circuit is like this. It's like a normal diode, and you have anode and cathode. So this is the anode and this is the cathode, and you have just a minute. You have a third terminal which is called the gate terminal. So this is the gate terminal. So this is the symbol of a thyristor. Okay. Now we'll discuss the different biasing situation of the thyristor. Now So there can be two biasing situation. One is the anode positive with respect to cathode, or the anode negative with respect to cathode. Okay, so first I will discuss if the anode uh, is kept positive with respect to the cathode. Okay, so how many junctions we have? We have four layers. Okay, if we draw in opposite direction, this is anode and this is cathode, and this is your PN, and we have junctions like this. We have this is the junction 1, this is the junction 2. So this is the one PN junction, this is another PN junction, this is another PN junction. So we have three PN junction overall. Okay, and if we relate with the previous structure, we can have the gate terminal from this P substrate. So this is the gate. Okay. Now, first I will discuss what will happen if node is positive with respect to the cathode. What are the condition of the junctions? So that means we have junction 1, junction 2, and junction 3. So what we can say about this junction 1, what we can say about this junction, and that is the biasing. I'm asking the biasing one. What about the biasing condition of junction 1? What is the biasing condition of junction 2, and what is the biasing condition of junction 3? Anybody want to say something on
So
this?
J1 forward bias,
J1, J3 forward bias, J2
J1
Why
reverse bias.
reverse
why
bias.
why J1 forward bias?
So J1 getting positive or yeah, in J1 junction P is
Okay,
getting positive and
okay.
J3 junction NP also getting negative. So but J2 junction N is getting positive. So
Which one?
so
J2. What
J2
about
J2
J2?
junction N is getting so J2 junction N is getting positive and P is getting negative. So that's
Okay,
why it's reverse.
okay. So basically, if this is positive, if this junction is positive, what about this substrate and this junction is positive and negative? Okay. What about this? This is positive and negative. What about this? This is positive and negative. This is how you can answer this. This is how the space charge regions are created between the two substrates. Now you can answer this. Now what about this PN? What was the first PN junction? J1. This is a forward bias, isn't it? What about the J2? N is positive, P is negative. So we can say it is reverse biased. What about the J3? P is positive, N is negative. So it is forward bias because P positive and negative. So that means when this anode is positive with respect to cathode, in case of diode, we can say if the anode is positive with respect to the cathode, then diode will conduct because it is forward biased. Because in diode we have only one junction, but in this particular device we have three junctions. and out of these three, only two has been forward biased, but uh, one is reverse bias only. Okay, so that means in this situation also the SCR of thyristor will not conduct, that we can say, because at least one junction is still reverse biased. Okay, next I will discuss the another condition where anode, or you can say cathode, is positive with respect to anode. Now let us draw the situation, and you just try to answer this. Same configuration I will draw. So here we have anode, here we have P N, okay, and here we have the gate. Here we have the cathode, and we have three junctions. So junctions are J1, J2, and J3. Okay. Now, what about sorry? What about J1? What about J2? And what about J3? If this is negative with respect to this, try to answer.
স্যার উল্টো হয়ে যাবে আগের কেসে
মানে কি?
reverse
J1
forward reverse
J3 reverse, so J2 forward.
J1 and J3 will be reverse biased and J2 will be forward biased.
Okay, so that means again we can write this before answer this. বলো কিছু বলছো?
It's just vice versa of the previous.
Okay, so that means if it is negative with respect to P is negative with respect to N, so Jn is reverse. J2 is forward bias because you see P is positive with respect to N. So this is forward. Now you just tell me, will it conduct in this biased condition?
No sir.
No, sir.
Why?
Sir, because two junctions are reverse biased.
Two junctions are reverse bias.
Still
That means
reverse.
this is worse condition compared to the previous one, isn't it? The previous case only one junction was
Yes, sir.
forward biased. Now you have two junctions are forward biased. Sorry, reverse biased. In previous case, only one junction was reverse biased. Here, two junctions have been reverse biased. So how it will conduct? So that means, so it will be again blocking the current. Okay, so in both the cases, it will block the current. It will not allow the current to pass through. Okay, so though the first condition is called the forward bias, actual forward bias condition for thyristor, and the second condition is called the reverse bias condition of the thyristor. Okay, now then how it will conduct? Okay, so only it will conduct if we apply or if we apply some biasing in the in the in the J3. That means if we apply some voltage in the gate signal, then only it will conduct. Okay, is that clear? So that means from this analysis, we can say the SCR has almost same blocking capability voltage blocking capability in both the direction, that means in the forward direction and the reverse direction. Okay, so forward reverse means this both the biasing condition. In forward biasing condition and the reverse biasing condition, it has same blocking capability. Not all the device available in power electronics has this feature. Okay, so we can write also here that thyristor have almost same voltage blocking blocking capability in both the direction. Okay, so no other power electronic devices has this ability. Only thyristor has. Okay, now when this anode is matched positive with respect to cathode, so that condition, what is that condition called for thyristor? When the anode is positive with respect to cathode, A is positive with respect
Forward blocking mode.
Forward block.
Forward bias.
no,
Forward blocking.
Forward bias.
the forward bias condition. It's not blocking capability is different. I'm
Yes,
asking
yes.
what is this condition called? Is
No, sir,
respect
the
to,
forward.
it's called the forward bias, simple forward bias of thyristor. Forward bias condition of thyristor. Okay, so this is a forward bias of thyristor. Now, in this condition, if we apply a voltage pulse, where in the gate, if we apply a voltage pulse, then the so that means we don't need any continuous voltage. Remember this point. So we don't need any continuous voltage in the gate. We need only a pulse. Though the pulse should be a sufficient pulse width. Okay, so this width should be sufficient. Not only that, impulse also you can provide, not like this. So you need a pulse, but that pulse should be should have sufficient width. So if we apply a voltage pulse in the gate terminal with respect to the cathode, obviously, because cathode here the reference is cathode, because anode voltage is positive with respect to cathode. Here also we have to apply some gate to cathode voltage. The pulse will be with reference to the cathode. So if we apply a gate to cathode voltage, a positive voltage in form of pulse, okay, so then this device or this thyristor starts conducting. How, what happens so that it starts conducting, and why only this pulse is required, not a continuous voltage signal in the gate, that I will discuss. So that can be discussed with a different topology. Okay. Now next I will discuss the characteristics of thyristor. So the VI characteristics of thyristor. VI characteristics of thyristor. Okay, so I will draw first, then I will explain. It is like this. It's a straight line. Okay, and that is for a particular gate current. For different gate current, this characteristics will be different. Okay, now this is for, you can say this is for I0. Okay, and suppose this is for IG1, this is for IG2, and this is IG0. Okay, this IG1 is more than IG0 because IG0 is 0. If we, that means if we go for higher gate current, then this value, which is called the uh, VB0 or forward blocking voltage, that will be reduced. Okay, and in the opposite direction, the characteristics is similar as diode. That is, there will be some breakdown after some certain reverse blocking voltage. Okay, so this is called the reverse blocking voltage. Okay, so this is the characteristics for thyristor. Here we have the current and here we have the voltage. So this is the IV characteristics because uh, it's basically coming from this diode. So therefore, generally in electrical, uh, we use generally VI characteristics. But as it is an electronic device, therefore we use the IV characteristics. Thing is similar, but we look the thing in different way. Okay, now there are two things. So one is called the latching current and that is the holding current. So this value is called the latching current. Okay, and when we'll reduce the, so I will discuss this later so that you, because latching current and holding current are two different values and latching currents are generally more than the holding current. So latching current is there, is that which is required, which is uh, there during the turn on of the thyristor, and holding current is that current which is there, minimum current, holding current also the minimum current which should be there, passive, which should be there between this anode and cathode during the switch off of the thyristor. So that is the difference. Okay, and this holding current, so holding current will be somewhere here because as I told you that the latching current is always more than the holding current. Hmm. And what is this? What is this VB0? Can anybody tell me? I've already told you that.
Breakover voltage.
Hmm?
Blocking voltage. Forward block
Forward
voltage, sir. Forward blocking.
Forward blocking a breakdown.
Breakdown.
break over
নাকি
Blocking.
anything you can write.
okay.
ফরওয়ার্ডে জেনারেলি ব্রেকডাউন বলি না, আমরা ব্লকিং বলি, সেই জন্য ব্লকিং বলা যায়, ব্রেকডাউন বলা যায়। And what is RV? RV is the reverse, so same thing, so reverse voltage. IL I will discuss this IL and IH term more in detail later. So it's a latching current, and IH is the holding current. You just remember these terms only, because these terms are very important for thyristor. Okay, so this is the characteristic. That means you can say diode, if in case of diode, what type of characteristics we get? In case of diode, we get this type of characteristics. Here also we get similar characteristics, but as without the gate current, the thyristor doesn't start conducting. So therefore, this particular zone it has. So this particular zone is for the giving the control to the gate. Otherwise, it is similar to the. So once the thyristor, the device starts conducting, it follows the characteristics similar to a diode. Okay, so this part is similar to diode. Okay, so only the starting phenomena is different. So we need additional uh, additional control signal to start the device. So that is the difference here. Okay, বুঝতে পেরেছো? So this is the difference, and in the reverse side it is almost same. Okay, now what is IZ0? IZ0 is the okay, so IZ0 is the zero current of zero gate current. Okay, and if you don't have any gate current, then what is the voltage required to switch on the thyristor? So that is nothing but the forward blocking voltage. So only to puncture the junction 2. Okay, so in the forward bias condition, the junction 2 is only reverse bias. So that means this VB0 is required to puncture that particular junction, and conduction will start. Okay, and if Ig is greater than 0, Ig has some finite value, then this voltage, so this particular voltage will be less compared to the value at Ig0. বুঝতে পারছো? Okay, so if Ig equals to 0, then the ACR can withstand maximum voltage up to what voltage? VV0. Now the working of this ACR, working principles of this ACR is generally explained by a two transistor model. So that I will discuss today. So working of ACR. working of SCR. Okay, so that means as I already told you that in the forward bias condition of SCR or thyristor, if we apply a small uh, gate, a small current signal to the gate, then the SCR starts conducting. Okay, so that but there should be sufficient gate to sorry, this anode to cathode voltage, otherwise it will not conduct, it will not start conducting. Now here we generally explain this working by two transistor model. Two transistor model. So if we see this carefully, so you have four layers, so P, N, P, N, and what is at the top? You have anode, here you have gate, here you have the cathode. Now you see from here you can see two transistor. So that means one is PNP transistor, another is NPN transistor. So suppose this is the PNP transistor. You just see. So this is the PNP transistor. And also you have another transistor, which is the NPN transistor. So this is the NPN transistor, isn't it? So that means you can see two transistor from this device. Okay. So PNP and NPN transistor. Okay. Now if I draw this transistor by their symbols and their terminals, how it will look like? This is the transistor 1, which is a PNP transistor, and this is the transistor 2, which is an NPN transistor. Can you visualize this similarity between this thyristor and these two transistors? You just see carefully. কি বুঝতে পারছো এটা?
Yes,
Has
yes.
Yes, sir.
Okay. Now for PNP transistor, now what is this alpha? Alpha is basically IC by IE. Okay, but there is another current we neglect that, but here we should consider that is the ICV0, that is the minority carrier current. Okay, so generally we neglect that, but we have to consider this. So that is called the ICV. So this is your CB. So this is the base and this is the collector. So ICB 0. Okay, so this current will flow from base to the collector. So therefore, we can write, instead of writing this IC equals to alpha IE, we also have to add this value. So IC B01. So reverse saturation current, or it is called the minority current. So this is due to the thermally generated carrier. So this ICB01, one for transistor. So this one I have used for transistor 1. But this ICB0, which is called the reverse saturation current, that is due to the thermally generated carrier. This value is very less compared to the actual value of IC and IE. Okay, and for this we have IE equals to, so this is the IC. So for PNP transistor, we can write IC equals IE equals to IC plus IB. So this is the IB. Okay, and this
Sir,
IC,
in E2 the
bolo,
sir, in case of T2 transistor, the emitter side should be K, right?
emitter,
Emitter side shouldn't be towards K, my cathode. In case of
emitter,
T2 transistor.
correct. এটা বলতে চাইছো?
Yes,
Now it is
sir.
okay.
Yes, sir. Now it's
Okay,
fine.
now it is okay. Now this is IE plus IB. So that means the IB, we can write this 1 minus alpha IE. So that is another identity. Okay. So alpha is the gain IC by, divided by IE. Alpha, there are two gains, for exist for bipolar junction transistor. One is the alpha gain and one is the beta gain. Alpha gain is the ratio between the collector current and emitter current, and beta is the ratio between the collector current and the base current. Okay, so here we have taken alpha, and for this transistor, this is a general expression. Okay, so now I will write all this for these two transistors. Okay, now this current should be IC, but it is not IC plus this value. So that means this IC should be actually alpha IE. Okay, alpha IE plus ICB01, because this current also will be added with the collector current, isn't it? Okay, so generally collector currents are alpha IE. It's okay, but again, if we consider this ICB01, so that ICB01 will be added with this. But here this current is not IE. This emitter current is basically this emitter current is equals to the anode current, IA. Isn't it? So this is the IA current. So that also we can write alpha IA plus ICB01. So this is this current, so which is flowing this in this path. Okay, the current which is flowing in this path is alpha IA plus ICB01. Okay. Now what about the current which is flowing in this path? What is the current? Actually, the current is flowing IB, but as ICB01 is going through this collector and coming out from this base, so we have to write IB minus ICB01. Okay, so this current is basically IB minus ICB01. So ideally it is IB, but if we consider the reverse saturation current, so that should be subtracted from this IB value. Okay, and also we can write, as we have seen that IB equals to 1 minus alpha IE, so that is equals to, we can write 1 minus alpha I. So instead of IE, I will write IA. So 1 minus alpha IA minus ICB01. Is that clear? So that is the actual current which is flowing through this path, which is flowing in this path. So 1 minus alpha IA minus ICB01. Okay, so this is complete of this T1 transistor. Now come to the T2 transistor. Now in T2 transistor, the reverse saturation current between this collector and base will flow in this path. So that is the direction of ICB02. Okay. Now what will be the base current of this? That is which current is flowing here? That is IB2. There it was IB1 minus ICB01. Here it will be IB2 minus ICB02. Okay. Is that clear? Now, which current is flowing here in terms of transistor 2 current? Because one part there will be with respect to the emitter of the transistor 2. What is that part? বলো?
স্যার আইসিটা যোগ হবে মানে কালেক্টর কারেন্টটাতে এখানে IB1 minus ICB1 plus IC
না, এটা 1 আসবে না। আমি বলছি in terms of, so
এটা
forget,
IC2
হ্যাঁ, forget about this transistor is over. So এই ট্রানজিস্টরের ব্যাপারটা হয়ে গেছে। Now come to this transistor. So for this transistor, if we see only this transistor, what will be this current? This current, what is that current?
IC2 plus ICB2 CBO2
IC2, let me write. So what
plus
is the saying?
ICBO2
IC2 plus ICBO2, correct. So that means
ICBO2
now what is IC2 in terms of IE, or rather IE2? Well,
alpha E2.
alpha IE2, correct. So not alpha 2. We should
Alpha 2 ID2.
we should distinguish between this alpha, because two transistors are different, so therefore gain also will be different, so we should differentiate. So here we should write alpha 1, and here we should write alpha 1, and here we should write alpha 2. So alpha 2 alpha 2 IE2, isn't it, plus ICBO2. Now it is correct, equals to, what is IE2 here? Here emitter current for transistor 2 is basically the cathode current, isn't it? Here the emitter current is basically the cathode current for the main thyristor. So therefore this we can write, instead of IE2, we can just write IK, cathode current, plus ICVCO2 will be as it is. Is it clear? বোঝা গেছে?
हाँ sir.
Okay, now instead of this IB2, what you can write? We can write 1 minus alpha 2. What we can write instead of IE? We can write IK, because emitter current for transistor 1 is nothing but the collector current of thyristor. Sorry, transistor 2. The emitter current of transistor 2 is nothing but the collector current, sorry, not collector, the cathode current of thyristor.
Last step টা repeat করবেন, I could not get it.
Which part? It's IB2. এই
So
জায়গাটা
the 1 minus alpha.
এটা কি করে এলো?
Yes, yes, yes.
Now you just see
Yes.
transistor 2 for IB2. This you see this expression. Now IB you can write
Yes.
1 minus alpha into IE, isn't it? For this transistor you
Okay,
should
okay, so
write
understood,
alpha to IE, but here your
I
IE equals
I
to
equal
IK.
to IK.
And here your
Yes,
IE equals to IK, cathode current. For this particular transistor,
yes,
emitter current equals to the cathode current of the overall thyristor. So therefore we can write this.
yes,
Now it is clear. Now here
yes.
we'll see the gate current of the main thyristor. So here you have the IG. So these are the different components of current. Now we'll try to write a few equations on this. Now first equation you see, if we apply some sort of KVL at this point, which point I am encircling. So at this point, if we apply some KCL, then what we can write? What we can write? So we can write alpha 2 IE, sorry, IK, not IE2, better to write IK. So alpha 2 IK plus ICBO2 equals to what? বলো? Equals to কি হবে? Both the currents I have written.
1 minus alpha 1 into IA minus I0.
So 1 minus alpha 1, that means this part, this term. So 1 minus alpha 1 IA minus ICB01. So this is the equation number 1. Now another KCL I will apply over here. Okay, so what you will get? First incoming current is IG. Second incoming current is this current. So that is alpha 1 IA plus ICB01. So these two currents are incoming to this node. And what is the outgoing current? Outgoing current is 1 minus alpha 2 IK minus ICB02. বুঝতে পেরেছো? These two equation, you just check whether you have understood this two equation or not.
Okay, sir.
Okay. Now from these
Yes,
two
sir.
equation, what we have to do, we have to eliminate IK and we have to write the expression in terms of IA only. Okay, so you just eliminate IK and solve for IA. Now you just tell me what is the value of IA. I am leaving this to you. You just try to eliminate IK, the cathode current, and in terms of anode current, you have to write the expression. So in the expression, you will have gate current, ICB01, ICB02, alpha 1, alpha 2, etc. Quick. কে বলতে পারবে তাড়াতাড়ি? হয়েছে?
Sir, alpha to IG.
হুম
Sir, in denominator, alpha to IG plus ICB1 plus ICB02
হুম
in denominator 1 minus alpha 1 minus alpha 2.
Okay. Is this? We just check.
Yes, sir.
Okay. So this expression that we obtained for the anode current. Okay. Now you see, if the value of alpha 1 plus alpha 2 approaches to 1, what will happen to this IA? IA tends to infinity, isn't it? So if the value of alpha 1 and alpha 2 approaches to 1, then the value of anode current will tend to infinity. Okay. So when T2 becomes on means the alpha 2 increases. Okay. Now when the T2 will be on, when the T2 transistor will be on, when its base current will be flowing. Now what is the base current of T2? Base current of transistor 2 is basically coming from the gate. So that means when you are providing the gate signal to the thyristor, actually you are trying to switch on the T2 transistor. Okay, so when you are supplying the sufficient gate current, actually this gate current is basically the emitter current for transistor 2. And if you can remember from your discussion on transistor, if the base emitter current flows, then the transistor becomes on and all the gains of the transistor getting increased. So that means when the transistor 2 becomes on, its gain, that is the alpha 2, gets increased. Okay. Now if alpha 2 is increased, what about the alpha 1? So if alpha 2 is increased means the gain, so here it is the emitter gate, so the collector, again the collector of this particular transistor is connected with the transistor 1. So that is the base current of the transistor 1. So that means when the transistor 2 will be switched on, it will try to switch on the transistor 1 because its collector is connected with the base of transistor 1. As a result, the transistor 1 also will start turning on. So that means the alpha gain of the transistor 1 will also increase. Is that clear? Okay, first alpha 1 will try to increase, will start increasing, then alpha 2 will start increasing. So when these two value will be that the summation of these two value will be near to 0. Sorry, not near to 0, near to unity. As I have shown here, when the summation of these two alphas, that means alpha of transistor 1 NPN transistor and alpha of PNP transistor, if this summation becomes almost equals to 1, then the IA will be very high, and that is called the regeneration of SCR. That is called the regeneration of SCR. Regeneration of SCR. So this is called the regeneration of SCR. So once the SCR becomes turned on due to this regeneration, okay, so then what you can do, you can withdraw your gate signal. You can reduce the gate signal. Okay, because automatically these two transistors will help each other to remain turned on. Okay, so this is how we can explain the working principle of thyristor. Any doubt?
Sir, if we do IG0, then IC transistor 1 IC will be how will get power IC.
IC? IG0.
Yes. So
But
last point I was যদি IG0 করে দিতে
IG0 যদি করে দাও, তো অলরেডি তো IA বেশি, এই এক্সপ্রেশনে যদি IG0 করে দাও তাতে কি এসে যাবে? If your this current is very high, so if this gain is very low, so the denominator is very low, so that means the IA is very high. So this part, if this part is very low, you don't need this IG. তাই না? তোমার এই ডিনোমিনেটর যখন অনেক ছোট হচ্ছে, though this ICB01 and ICB02 is very less, but as the denominator is also less, then the ratio becomes high. So you will have sufficient anode current in spite of this zero gate current. But initially you need the IG to turn on first transistor 1, then first transistor 2, then transistor 1. Okay, so initially you require this gate current first to turn on the transistor 2, then transistor 1. Once both the transistor start switched on or turned on, then they will help each other to remain turned on. So you don't require any gate current. Okay, so unless
but
the
sir
current,
if
বলো
স্যার বলছি যখন টার্ন অফ মানে আইজি না দেওয়া হবে তখন তো আইসিবিও 2 থাকবে বাট ইট ইজ ভেরি লেস
কোনটা তখন আলফা বলে কিছু থাকবে না তো in the denominator. If we don't have IG at the beginning, then alpha values are very less, almost 0.
Yes, sir.
There is no gain.
Yes,
two
yes.
transistor at the cutoff state,
Yes.
তখন ডিনোমিনেটরটা 1 হয়ে বসে রয়েছে,
Yes.
and
Hmm.
মানে ওপরেরটা হচ্ছে in the order of milli ampere or less than milli ampere,
Yes.
ICB01 আর less than that. তো সেইখানে তলায় 1 মানে হচ্ছে IA is very less.
Yes. Got it.
Okay. Any other question? So if you don't have any other question, I will stop the share.